Dear students, our next topic is the error detecting codes. In this topic, you have to know that when the binary data is transmitted through a long distance or binary data is processed, there is a chance to make noise and it alter the distort or its contents. That is, some noise is added to this binary data. That is, in this case, the signal that is ones may get changed to zeros and zero may get changed to one. So because the digital system must be accurate, the error can pose a serious problem. So we have to make the system must accurate, and this error can make a serious problems. And first of all, we have to know that what is a parity. Parity is an extra bit that we have added to the message signal. That is called a parity. So it is a concept to detect errors. We have to detect the errors and rectify it. A single bit error is detected by it. In this figure, we can see that a transmitter is represented by Tx and a receiver is represented by Rx, and a 4-bit signal is passed. And we have to, when we send a 4-bit signal, also we have to send an extra bit to rectify the errors. And in the examination, you will have acts like this. The parity are of two types, that is even parity and odd parity. You simply understand what is even parity and odd parity. In case of an even parity, suppose a signal that is 0, 1, 0, 0. And I have to ask if this is or change this signal to an even parity. Even parity means you just counting the number of ones in the signal. If the number of ones in the signal is odd number, you have to change to even number by adding another one, that is the parity bit. That is simply is termed as even parity. And in this question, the original signal is 0, 1, 0, 0. And I have to write that the parity bit is 1. That means we have to make this the 1 to make even. That is, we have to add another 1. So the reason, if the number of ones in the original signal is odd, we have to make it even by adding a parity bit. That is, if the number of ones in the signal is odd number, we have to make it even by adding another 1. That is called even parity. Same like that, in case of an odd parity in this same question, if 0, 1, 0, 0 to make odd parity, we just add a 0. That is, no one is added. So it is still in the odd parity. That is all about the even and odd parity. The next question, 1, 1, 0, 0. We have to make this as even parity. So just counting the number of ones in this question, that means just counting here 1 and another 1, that is 2. So it is in the even form. So we write the parity as 0. This no 1 is added, and the number of parity signal we have to add is 0. That is in the even form. Therefore, the number of ones in the original signal is even, the parity we add is 0. The same like that, odd parity in the question 0, 1, 0, 0. Just counting the number of ones in the signal. Here the number of 1 is only 1, that is odd number. So we add the parity as 0. The second question, here number of ones is 2, that is number of ones is 2. So we have to make it as odd. So in this case, in the parity, so we have to add another 1. So it is 3. In case odd parity, the number of ones to make to add odd. Some another examples, odd and even parity in 8421 code. Here the decimal numbers 0 to 9 and the 8421 BCD, the odd parity. The first case, here 0, 0, 0, 0. Odd parity make we have to add 1, and even parity is we have to make 0. Second question, 0, 0, 0, 1. This 1. Odd parity means no 1 is added, that is only 1 in this. So it is already in the odd case. So in odd parity we have to add 0, and even parity we have to add 1. That is all about the odd and even parity. So another question, in an even parity scheme, which of the following words contain an errors? We just counting the number of ones in this question. That is, first of all, the question, you see the question, it is even parity scheme. which of the words contain an error. Now just counting the number of ones, that is here 1, here 2, here 3, here 4. It is in the even state, and so there is no error and no parity is added, that is with the number of parity added is 0. Next question, it's even parity question. Just counting the number of ones, that is 1, 2, 3, 4, 5. Here the number of ones is in the 5, that is in the odd state. So we add, so there is an error in the question. So in order to changing the error, we have to add another 1, that is the parity is another 1 is added, that is the error correction. In this case, in an odd parity scheme, which of the following words contain an error? Just counting the number of ones, that is here 1, 2, 3, 4, 5. Here the 5 case, 5 and already it is in the odd parity case. So in the question, in an odd parity scheme, which of the following words contain an error? Here it is in the odd state and there is no error. So another question, here 1, 2, 3, 4, 5. In this case, the number of ones in the word is 5 and no error. That is called the odd and even parity scheme.